Here we go. Okay. So now we're going to see the formula for determining the distance between 2 points in the Cartesian plane. Well, come on, there we go. Suppose now you have 2 points, okay? P and Q, okay? So let's say you have 2 points here, P and Q. Okay. So here, right? Let's say P and Q look like this. These are the X and Y coordinates. I mean, we're just assuming this is how they are in the Cartesian plane. But it doesn't really have to be like this. You know, it's just, they could be anywhere. The distance between them in the Cartesian plane, it turns out you can actually calculate it using this formula. You can calculate it using this formula. Okay. It's actually the same as the length of the line segment connecting P and Q together. You know, if you have 2 points, right, you could connect them by a straight line segment. And the length of it is actually the distance between them. And that's what we have here. I mean, this will come up in the example as well. What are we actually doing here? We're subtracting the X coordinates from each other, squaring that difference. And then we're subtracting the Y coordinates from each other, and squaring that difference. We're adding that one of those 2 squares, then we're taking the square root. Okay. What's nice is, as you'll see in the example, it really doesn't matter what order you subtract. I mean, here we have x sub 1, the x coordinate of P, minus the x coordinate of Q, excuse me. But you could go the other way around because you're squaring. So for instance, let's say our points were 1, 4 and 2, 7. And let's say P was the point 1, 4. And let's say Q was the point 2, 7. Okay? So P is the point 1, 4. Q is the point 2, 7. Okay? Let's find the distance between P. Let's find the distance between P and Q. Okay, well, using the formula, we have our X coordinate, right? We have 1 minus 2. It's over here. 4 minus 7. And we're squaring those differences. Here, you know, I did this for the other class. Let me do it for you guys, for everyone here, I mean. Okay. Here we have X sub 1 as 1. X sub 2 we have as 2. Okay. We have Y1 as 4. We have Y2 as 7. Right? So here, okay, using the formula, we would have 1 minus 2 squared plus 4 minus 7 squared. And doing so, we get the square root of -1 squared plus -3 squared, which is the square root of 1 plus 9, which is the square root of 10. But this is what I was trying to say before. Let's say we chose the other point to be P and the other point to be Q. Let's just say we decided to do that. Well, what's going to happen? Let's see. In this case, okay, we have X sub 1 as 2, X sub 2 as 1. So essentially, we're interchanging 1 and 2 in the X coordinates. For P, we have Y1 is 7, Y2 is 4. So we're also interchanging the Y coordinates in the formula, right? you can see that, right? We have 1 minus 2 squared, 2 minus 1 squared, 4 minus 7, 7 minus 4 squared. But you're going to get the same answer because you're squaring. Namely, you're going to get the square root of 1 plus 9, which is the square root of 10. That's what I was trying to say. Okay? I mean, again, look at what we're doing. We're just subtracting x coordinates and squaring that difference. Same thing with y coordinates. Subtracting and squaring that difference. All right. Okay, I hope this makes sense. Are there any questions? Okay. Now, why is this formula true? You know, in math, we like to prove things. It's not like someone just came along and said, here's the distance formula, no questions asked, like it or leave it, or so to say, okay? You know, we can verify that that is the distance. And we're actually going to verify that now. I mean, I'm not going to ask you to prove the distance formula on an exam or anything like that. I just like to illustrate why it's true. And it actually involves a famous theorem called Pythagorean's theorem. Okay. So let's suppose P and Q are like this. I mean, it really doesn't matter where they are, P and Q, in the Cartesian plane. You know, it doesn't matter. But let's say without loss of generality, they're both like so. Okay. All right, now, what we can do is this. We can draw these dashed lines, okay? You know, so for instance, from P, we have this dashed line drawing to the left and to the right. And we also draw one down to the x-axis. And really, from the way we plot points, vertically down, this is x sub 1. To the left, we have y sub 1. Okay? It's almost like it's like the way we plot points, but in reverse. For Q, we do the same thing. To the left, right? To the y-axis, we get y2, right? That's the height above the x-axis. Vertically down, we're at x2, okay? Now, what is this point over here? Well, this point's going to have coordinates x2 and y1. Okay? Again, how do I know that? Well, notice this line is vertical, and two points on the same vertical line or vertical line segment, or in this case, a dashed line segment, they have to have the same x coordinates. 2 points on the same horizontal line segment, right? This is on the horizontal line that passes through P, so they both have to have the same y coordinates. So that's what these coordinates are. Okay, that's really good. Now, why is that good? Well, you can see that we have a right triangle here, right? And the distance between P and Q is the length of the hypotenuse. Again, that's the side opposite the 90-degree angle. That's what this rectangle indicates, the 90-degree angle, as you can see. Okay, that's cool. So what is the length of these two sides? Well, this length here, what would that be? That's going to be y2 minus y1, right? You have y sub 2, but then you're throwing away this piece. So we get this. Here's the same idea for this side. We have x sub 2, but then we subtract off x sub 1, which is this piece. And we're left with this. So this is the triangle we get, the right triangle. And of course, you know, I take away the x and y axis, so we really have this. But now you can see that, yeah, Pythagorean's theorem is going to be used. Here I basically made the lines not dashed. So how will we get the length of the hypotenuse? How do we get the length of this side, which is the distance from P to Q? Pythagorean's theorem says the length of that line segment squared is the length of this squared plus the length of this squared. as you can see. And then you just take square roots. So that's just a sketch of why the distance formula is true. Again, I'm not going to ask you to prove it on an exam or whatever. I just like to illustrate why it's true. So at least you see why it's true.